Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function. So here in this class we'll evaluate this integral in which we have to make use of the derivative property of Dirac delta function, right? So we have to evaluate this integral that is from minus 2 to 2, and we have e raised to 2x minus 1, and here we have the third derivative of delta function, that is delta triple prime x minus 1 dx, right? So we'll see how we can evaluate this integral by making use of the derivative property of Dirac delta function. So let us start. So the derivative property of Dirac delta function states that if we have a function, say f of x, which is associated with the Dirac delta function, and if we have this integral that is minus infinity to infinity f of x, and here we have the nth derivative of the delta function, and the point of consideration is a, right? So the value of this integral is given by minus 1 raised to n, and here we have the nth derivative of this function, that is f of x. So we can write the nth derivative of f of x evaluated at this point, that is x is equal to a. So here we have a, right? So this is the derivative property of Dirac delta function, which is used to evaluate this integral. So now let us call this integral as I, and let us compare this integral with this one. Right now, see here the limits are from minus infinity to infinity, but here we have the limits that is from minus 2 to 2, and we can see that at this point, that is a is equal to 1, it lies within the boundaries, that is minus 2 to 2, right? Okay, so if we compare this integral with this one, then the function f of x is given by e raised to 2x minus 1. So this is our function f of x. So here we see that we have a triple prime, right? That is the third derivative of the Dirac delta function is involved, right? So here these three dashes indicates the third derivative of delta function, and here we have the nth derivative. So if we compare these two terms, then the value of n is 3. This value of n, that is 3, it denotes the order of derivatives. So here the third derivative of delta function is involved, and here we have x minus a, and here we have x minus 1. So the value of a is equal to 1. So now the value of this integral I due to this result is equal to minus 1 raised to n, and the nth derivative of the function f of x evaluated at the point x is equal to a, right? So our n is 3, so we have minus 1 raised to 3, and here we have f of 3, that is the third derivative of f of x at a is equal to 1. So here we will write 1. So now minus 1 raised to 3 is minus 1, and here we have the third derivative of f at a is equal to 1. So this is minus f3 at a is equal to 1. So now our aim is to find out the third derivative of this function, and then we'll evaluate the third derivative at this point, that is a is equal to 1. So we have f of x is equal to e raised to 2x minus 1. So the first derivative, that is f prime of x, is equal to e raised to 2x minus 1 multiplied with the 2, because the derivative of the exponential function is the function itself, and then by chain rule the derivative of 2x minus 1 is 2. The second derivative is given by here we have this factor 2, and then we differentiate e raised to 2x minus 1. So the derivative is 2 times e raised to 2x minus 1. So this is 4 times e raised to 2x minus 1. Now let us find out the third derivative of f of x. So here we have the factor 4, and the derivative of e raised to 2x minus 1 is 2 times e raised to 2x minus 1. So this is 4 times 2, 8. That is e raised to 2x minus 1. So we have obtained the third derivative, right? Here we have the third derivative. So we can replace these 3 dashes by 3. So we have the third derivative of f of x as 8 times e raised to 2x minus 1. So let us substitute x is equal to 1, that is a is equal to 1. So we have the third derivative at x is equal to 1 is given by 8 times e raised to 2 times 1 minus 1. So taking x is equal to 1. So we have 8 e raised to 2 minus 1, that is 8 times e, where e is the exponential number, right? So let us substitute this value of third derivative of f of x at x is equal to 1 as 8e in this expression. So we have minus, the value of I is minus 8 times e, right? So the value of this integral is equal to minus 8 times e.